Today's video, we're going to go over flowcharts for triangle congruence. So your learning target is to use flowcharts to organize arguments for increasingly complex diagrams of triangle congruence. First, let's do a little overview and example of what a flowchart has. So over here, we are proving that these two triangles are congruent. So you're typically going to have three ovals with three reasons, all pointing to, with arrows, that the two triangles are congruent and how. So always think about what you're given, okay? And what you're given is usually marked here. So you're given that these two sides are congruent. You're also given that these two angles are congruent. And then you know something else. What else do you know is congruent from one of the properties that we talked about in the last lesson? Well, we know that these angles are congruent because those are vertical angles. The first thing is we know that angle Y is congruent to angle B. So I'm going to write that in an oval. And the reason is that it was given to us, right? It was literally given to us in the drawing. Then we're going to say that YA is congruent to BA. In an oval, that's your statement. And how do you know that those two are congruent? Because it was given to you. And then thirdly, we know that this angle is congruent to this angle. And again, we're not going to say, let me write it out. We're not going to say, if my pen works, angle A is congruent to angle A. Because what are you talking about angle A? We need to be more specific. So angle ZAY is congruent to angle CAB. And how did we know? By the vertical angle theorem. So now we have our angle, side, and angle. Therefore, we know that triangle ZAY is congruent to triangle CAB. And how do we know? By ASA. So this is what a typical flowchart will look like. Sometimes you might have another oval up here, and we'll see when we do that. But this in general is what a flowchart looks like. So let's go ahead and start. Let's prove that the two triangles are congruent using a flowchart. First, we got to think, is this SAS? Is this SSS? Is this angle, side, angle, or a hypotenuse leg? So let's see what's given to us. We're given that these two angles are congruent. That'll be really important information. So I have an angle. I also know that these two sides of the triangle are congruent because they're shared. And I also know that these two are congruent because it tells us that they're 90 degrees. So I have an angle, a side, and an angle. Therefore, I'm going to use angle, side, angle. So let's go ahead and start writing our flowchart. We know that this angle is congruent to this angle. And actually, there's another way you can start. It also depends on who your teacher is. Some teachers might require that you say, angle ADB is equal to 90 and CDB is equal to 90, and then go to another oval. But for me, I'm okay if you just say angle ADB is congruent to angle ADB, means I have to go from here, CDB. That's my statement. And the reason, is it was given to me. Okay, there's my angle. Now I'm going to think about my side. Well, side DB is congruent to side DB. And how do we know this? Because of the reflexive property. And I'm going to, be very short with my reasons. You can write more reasons like reflexive property of congruence. And then I'm going to say, well, these two angles are congruent, and I'm not going to say angle B is congruent to angle B, right? Because what does that even mean? But what I am going to say is specifically name it ABD. So I'll try to fit it here. ADB is congruent to angle, oh, I made a mistake. I can't say ADB. Why did I say that? Because I want to be focused on this angle that has to go in the middle. So ABD is congruent to CBD, angle CBD. That goes in an oval. And the reason is it was given to us by the tick marks. If you ever see tick marks, it's probably important and will need to go in an oval with the reason being given. So I have my three statements and my three reasons. I have my angle, I have my side, I have my angle. Therefore, I know that triangle ABD is congruent to triangle CBD. And again, oh, and there's your statement, the reason, angle, side, angle, congruence. Okay, so again, you don't have to have ABD, CBD. Maybe you started at B, that's fine. Triangle B, maybe you said bad, triangle bad, but your second part would have to say, if you went BAD, you would have to go BCD. And do you see how, okay, if I go BAD, I would have to go BAD, so it better go BCD, which it does BCD. So there's one example of a flow chart proving these two triangles are congruent by angle, side, angle. Let's go ahead and try another example. Let's prove that these two triangles are congruent by using a flow chart. So here's an important theorem that we need to know. The triangle angle sum theorem. That just tells us that the three angle measures of a triangle will always add up to 180 degrees. So even though it's not given to us, we can figure out what J is and we can figure out what N is, because this number will be 180 minus 56 minus 29. Subtracting those two will get us that. And I'm assuming it's going to be 95 degrees. I'm assuming. Okay, and then this one, again, 180 minus 95 minus 56, I'm going to assume is 29 degrees. So we figured out what these angle measures are. Can we use one of our 5 to prove that these are congruent? Well, it doesn't have anything about a hypotenuse and leg. I do have an angle. I have 2 angles, but do I have anything about sides? Not really. So those two cancel out. I don't know anything about the sides. So we can't prove if these are congruent based on our 5 postulates. We have angle, 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 and I know that they look congruent, but again, we cannot just assume unless we're given or told information that tells us that they are congruent. But here we have nothing about the sides. So this would be not necessarily congruent. It could be, so that's why I'm not saying not congruent. It could definitely be congruent. But based off of angle, 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 AAA, that is not one of our postulates for proving that triangles are congruent. Okay, so let's move on. But the triangle angle sum theorem is important. Prove that these two triangles are congruent using a flow chart. Ooh, this one looks a little bit tricky, but okay. So visually, these don't look congruent, right? This triangle looks bigger than this one, but you can't just say, oh, not congruent and move on. Let's see. We are given a few things. We are given that these two angles are congruent, so we have an angle. We're given that this side is reflexive to this side, therefore they're congruent because a line is equal to itself. But we're missing an angle or a side. There's nothing about sides, there's no tick marks, there's no length measures, so we're not going to have another side. Do we have another angle? Well, these parallel marks are kind of signifying something and signaling something in my brain that says, okay, the parallel marks might be important. I have two parallel lines cut by a transversal. What happens when we have parallel lines cut by a transversal? Alternate interior angles. We know that these two angles are congruent because of alternate interior angles. So let's go ahead and start our flow chart. This is one where it's not going to be just the typical 3-to-1 ovals. You're going to have an extra oval in there. So first, let's take care of our givens. Okay, let's take care of angle GFH. So this angle right here. Again, I'm not saying angle F. If you tell me angle F, I'm going to say, okay, this angle right here. Okay, so angle GFH is congruent to, let's think about this, a lot of markings here. Let me change it. So we said these two are congruent, right? Okay. GFH is congruent to GFH EHF. And how did I know this? Oh, you know what? Let me actually, let me write that lower, sorry. These two are congruent, these two are congruent. So let me write it down here. Angle GFH, oops, I cannot spell, is congruent to angle GFH EHF, not G. And I know that because it was given to me. I also know that side FH is congruent to side FH. FH is congruent. I'm actually going to do HF. And that's because of the reflexive property. I'm going to shorten it, reflexive property. Now I know that these two are congruent. But how do I know that they're congruent? How do I know that they're alternate interior angles? I know that because of these two parallel lines. So before I make the statement that those two angles are congruent, I must make the statement that GH is is parallel to FE. How do I know that? It was given to me. Now that I have stated that those two lines are parallel, now I can do an arrow to the third oval and say that angle, let me be careful, angle EFH is congruent to angle EFH GHF. How do I know this? Alternate interior, angles. Now that I've proven that because I have two parallel sides, therefore these two angles are congruent by alternate interior angles. I know angle GFH is congruent to angle EHF because it was given to me. And I know, I forgot my symbols up here. Don't forget those, please. FH is, and my congruent symbol is congruent to HF by the reflexive property of congruence. And so I can now confidently say that triangle, let's do GFH, I suppose, is congruent to triangle. Let's see if I go GFH EHF, I believe is correct. How do I know? angle, side, angle, right? I have an angle, I have a side, and I have an angle. Okay, so hopefully that helps. Typically, right, you're gonna have the 3 ovals to 1, but sometimes you might need to add that 2 lines are parallel in order to complete your full flow chart, okay? Always think about, how do I know that? If it wasn't given to me, how do I know that? It's gonna be some kind of property or theorem, okay? Next example. Let's prove, maybe if my screen will go next. Let's prove that these two are congruent. These look tricky. Go ahead and pause the video and try to see what angles you've got, what sides you've got. Do you have any parallel lines? If you need to visualize this better, separate the 2 triangles, right? You technically have 1 triangle here, 2 tick marks. Oh, this is so confusing. 1 here. And then another triangle here, 1 tick mark, 2 here. So maybe that helps you better, right? Like for me, now I know that these 2 are congruent and these 2 are congruent. So I've got 2 angles. So out of my 5 postulates, I've got HL, SAS, SSS, angle, side, angle, and angle, angle, side. I know I have 2 angles, so I'm not going to worry about this, this, or this. So I've got ASA and AAS. I'm looking for a side. What 2 sides are congruent? This one. They're sharing a side, right? This side is congruent to this side. So let's go ahead and start our flowchart. The first thing I'm told is, let's deal with these, right? These 2 angles. Because angle D is not being shared, it has only 1 angle here. I can say angle D is congruent to angle C. How do I know? It was given to me. Easy peasy. What else do I know? I know that this angle is congruent to this angle. I have to be careful though. DAB, CAB, a little confusing. Okay, so if I want to talk about this angle with this one, I can't just say angle A and angle B. I have to say angle DBA. Angle DBA is congruent to, let's see, DAB would be CBA. How do you know? It was given to you in the form of the little markings, right? What else do we know? Now we need to take care of the side. Side AB is congruent. AB, I'm going to go BA. And the reason for that, it wasn't given to us, but we know that they're congruent because of the reflexive, oh gosh, property of congruence. I've got my angle, and my side. So I can now finish my flow chart. I'm going to say triangle DAB is congruent to, if I go DAB, I have to go CBA, triangle CBA. How do you know? By angle, angle, side. Okay, so let me erase some stuff so it looks less confusing. All right, that is my completed flow chart for this pair of triangles. Pause the video, think about it, process it a bit, try it again on your own if you need to. So that is it for this video. I hope it was helpful.